Hello, a very good evening to all, and welcome to my class. Why we are here today? We are going to discuss our paper. I hope सबने पेपर अच्छा किया होगा. Yeah, good. So we are going to discuss the paper. What kind of difficulty you are basically facing? How many of questions you really think that this question need explanation and all. So we are going to explain each and every questions, right? And basically we are focused on those questions having many students facing problem related to such questions. Now we are going to discuss these questions as well, right? So let's start with the today's session, right? And yeah, this one is your first question. That is the product X formed in the following reaction. What product X is formed in the following reaction? So here we have a four option, right? A, B, C, D. Out of these four, now, which one is the correct one? So let me tell you first. According to you, which one is the correct option? सबसे ज्यादा टिक किस पे किया तुम लोगों ने? Yeah. Good, good. It means according to most of the student, the correct answer is B, right? So how can we, let's discuss why B is the correct option and how can we solve such kind of questions if they are coming in the examination, right? So the question asks the product X formed in the following reaction. So what is the compound here, beta? That is the OH group and that is CH2Cl group. And this will treated with AgNO3. Then what the formation of X takes place? So let's see the expression for this. When we treat this with Ag, then obvious AgCl will be formed. Cl is removed from this position, and as soon as Cl removed, na carbocation formation takes place, right? CH2 carbocation formation takes place, and to gain the stability of the carbocation, now what happened? One to ring expansion. There is a ring expansion. Formally, there are how many carbon? There are how many ring having how many carbon? That is a 5 carbon, right? And here the ring expansion takes place and now the ring becomes 6 member. That is the formation of OH having plus positive charge. Now when this positive lone pair and this carbocation they form double bond with each other and the formation of this will takes place. So what is the correct option, beta? That is option number B. Option B is the correct, right? Okay. Now the next question is, and it is one of the good question, I guess, and it is also very easy question. If someone knows the reactivity of aldehyde and ketone, then they easily predict the options very easily, right? Now, what the question asks? According to this question, now, what is the correct order of reactivity of the nucleophilic addition reaction of the following carbonyl compound? We know that with ethyl magnesium as well. We know that out of aldehyde and ketone, which one is more reactive, beta? This is aldehyde, right? And this is ketone. Okay. So out of these two, aldehyde and ketone, which one is more reactive? We all know aldehyde is more reactive. Why aldehyde is more reactive? Because in aldehyde, only one donor group, that is one R, is present. While in ketone, there is a two bulky donating group are present, which increase the stability but decrease the reactivity. That's why if I'm talking about the out of aldehyde and ketone, which one is more reactive, then obvious ketone is more reactive because it having only one R group. Okay. Similar, if I'm talking about formaldehyde, then formaldehyde is more reactive than aldehyde as well because in formaldehyde there is no R group, right? Only H group is present. It means formaldehyde is more reactive even than aldehyde. It means the reactivity depends upon the number of R group. As the number of R group or we say alkyl group increases, reactivity of the carbonyl compound decreases, right? So just use this concept and try to find out the answer for this question. And I guess most of you सबने ही सही किया होगा इस क्वेश्चन को, right? So let's find the correct solution for this question. Okay, so look at number one, that is formaldehyde. This one is a much more reactive. Now next move to the, that is it having H and C2H5. This is aldehyde and this is ketone. So the first is number one is most reactive. After this, third, that is aldehyde. Now this one is also ketone, this one is also, but this having a bulky group. So which one is more reactive? That is number two, and least reactive is number four, right? So this is the total overall order, that is first, three, second and four. So which one is the correct option, beta, out of A, B, C, D? Yes, D is absolutely correct. I hope is it clear to everyone? Any doubt, beta, related to this question? No. Okay. Now, next move to the next question, that is an organic compound P upon reacting with NH3. Okay, हमें नहीं पता यार कौन सा P है ये, लेकिन जब ये रिएक्ट कर रहा है ना किसके साथ, NH3 के साथ, it will form Q. It will form Q. Now, on heating Q, it give R, right? And R in presence of KOH, R in presence of KOH react with Br2 to form ethylamine, to form ethylamine, that is CH3, CH2, NH2. Now you have to identify the structure, that is which one is P, right? P is, what is P here? Beta, just observe very carefully. Okay, what we get here now, that is ethylamine. Okay, so let's see the reaction behind this. If I'm talking about this now, this is propanoic acid. So this must be, whenever propanoic acid react with ammonia, the formation of what takes place? The formation of amide takes place, right? When we heat this, and when the amide is treated with KOH and Br2, then the formation of amine takes place. And we all know this. Which reaction is this, beta? Hofmann's bromide reaction. Hofmann degradation. Hofmann's bromide degradation reaction is this, right? So this is how we can convert this and identify the organic compound P, right? So this is simple question, I guess. This question basically from a chapter amine. Okay, so this is not a medium or we say hard question. This is a very simple question, and many of you did very right? Okay. Now, next move to this question, that is which among the following is a false statement. So you have to identify beta the false statement regarding this. Si2 has a structure similar to that of CO2. Whether is it true? Yeah. Whether is it true? CO2 having a structure similar to SiO2. Next, natural Si exists only in the combined state. Okay. The third point state that Si can be prepared by reducing SiO2 with magnesium. And the fourth point state that Si does not exist in graphite-like structure, but exists only in diamond-like structure. So out of this four option, which option is going to false? Now I'm going to explain each statement, because you don't know, even in your next examination, the question are coming from this point only, right? So you need to know each and every point. Okay, that is the main motto here to discuss a PY with Q, guys. The main motto here is what? That you should learn every point. You should learn what type of question they are really going to ask in your upcoming examination and all. Okay, so I'm going to discuss each and every point right now. If I'm talking about point number A, what does it mean? It does mean SiO2 has a three-dimensional network structure of SiO bond, while carbon consists of discrete CO2 molecule, and SiO2 is a solid where CO2 is a gas. So this is not the correct one, right? The first statement state now SiO2 has a structure similar to that of CO2. This is not possible. SiO2 having a solid where the CO2 is a gas, because in SiO2 has a three-dimensional network of SiO bond, while the carbon dioxide consists of a discrete CO2 molecule, right? Now, so we got the answer, but even we have to discuss the other point as well. Okay, so if I'm talking about the point B, because of its great affinity for oxygen, Si always occur as oxidized silica, the SiO2, or in the form of silicate, which are the compound Si2 with the other metal oxide. So this is correct. SiO2, whenever it is treated with magnesium, it will form Si plus 2 MgO. So we can say that it can be prepared by reducing SiO2 with the magnesium. The reluctance of silicon to form p-pi bond to itself clearly shown by the fact that silicon does not exist in a graphite-like structure, but only in a diamond-like structure. It means except point number A or option number A, all options are absolutely correct, right? So I hope, is it clear to everyone? Okay. Now, this one is very important question, and if you know one simple formula, then you can easily draw such kind of graph, right? What is the question state now? Which of the following graph correctly represent the variation of particle momentum with associated with de Broglie wavelength? We all know that what is de Broglie wavelength, beta? That is lambda is equal to h upon p. It means according to de Broglie, wavelength and momentum are inversely proportional to each other, right? Wavelength and momentum are inversely proportional to each other. Okay, so out of this 4 gram, which one is correct, beta? Yes, tell me fast. Out of these, which one is correct? That is D, because here as we can see now, when the lambda is 0, then momentum is maximum. As the lambda goes on increasing, it means as the wavelength goes on increasing, momentum start decreasing and so on. So option D is absolutely correct for this question, right? Because we know that momentum is inversely proportional to wavelength, or we say wavelength is inversely proportional to momentum. Okay, now what is the next question? The next question states that, beta, to stop bleeding, FeCl3 is applied locally because कि अगर bleeding, if you want to control the bleeding, FeCl3 is applied locally because FeCl3 seals the blood vessel. FeCl3 change the direction of blood flow. FeCl3 react with blood to form a solid substance which seals the blood vessel. Yeah, FeCl3 cause denaturation of protein present in the blood. Yes, this is the absolutely correct one. That is option D. FeCl3 cause denaturation of protein. What is denaturation of protein, beta? What is denaturation of protein? That is whenever there is a change in some temperature or pH, the biological activity of protein is damaged, and this is called the denaturation of protein. So FeCl3 cause denaturation of protein present in the blood. Okay, so this is the fact. To stop the bleeding, FeCl3 is applied locally because FeCl3 cause denaturation of protein present in the blood, and it is a case of coagulation. It means it depends, it belongs to the case of coagulation. Now, question number 37. Which one of the following combination will produce H2 gas, beta? Yeah, out of these 4 options, in which H2 gas is produced. Yeah, you have to identify out of these 4, in which hydrogen gas is produced when the zinc metal is treated with NaOH, when the Au metal and NaCN aqueous in presence of air, when the copper metal and concentrated HNO3 are treated with each other, or Fe react with HNO3. So you have to identify the correct answer. So, I hope most of you know this in your 10th class itself. That is the zinc possesses both character. That is, it react with NaOH as well as HCl to form amphoteric nature, right? Zinc react with both of these. So whenever the zinc react with NaOH, then sodium zincate formed as well as hydrogen gas is also formed. So which of the following combination will produce hydrogen gas, beta? That is the zinc metal with NaOH. We can see here also, right? So when the sodium NaOH is react with zinc, then what is the formation? This is called, beta, sodium zincate. Okay, we normally denote as Na2 and Z. Okay, so this is the sodium zincate, right? Now, this is sodium zincate, and similar, if we treat Au gold with NaCN, then the formation of this complex takes place, not the hydrogen. Similar, when the copper react with HNO3, copper nitrate plus 2NO2 plus H2O takes place. Okay, so only option 1, in which when the zinc react with NaOH, formation of Na2ZNO2 takes place, right? I hope is it clear to everyone? Okay. Now, next move to the next question, and this question we were discussing in last class, that is our yesterday class. We were discussing this question, that is how to identify whether it is an inner orbital or outer orbital, diamagnetic or a paramagnetic, low spin or a high spin. So this kind of question we already covered yesterday. Okay, so we already covered this type of question in yesterday class. Even I'm going to explain you. I hope most of you did this question correctly, because this is simple question, and just concept based question. If you know the concept behind this, now if you know how to find the unpaired number of electron, which is a weak ligand, which is a strong ligand, then you can easily solve such type of questions, right? Okay. So which one of the following is an inner orbital complex as well as a diamagnetic in behavior? Okay. So if someone asks inner orbital and diamagnetic, we already know if the complexes are inner orbital, then itself it become diamagnetic. Okay. If the complexes are inner orbital, then it must having low spin. So these are interrelated things, right? So out of these, they all having 6 coordination numbers. So out of these, zinc, chromium, nickel, cobalt, just observe the ligand carefully. All having same ligand, all having same ligand, right? So NH3, all having NH3 of ligand. Now, what important thing here, na? If I'm talking about NiNH3, Ni having how many charge, beta? Ni having +2 charge. And in +2, their electronic configuration is 3d8. Similar, cobalt +3. Cobalt +3. Science teacher very cruel, mange fair copy. 3D 7 hota +2 mein. This will become 3d6. Okay. Now, if I'm talking about zinc and NH3, here also Zn in +2 form. +2 form means what, beta? 3d10, right? If I'm talking about chromium, then chromium NH36, right? So what is chromium NH36 here, beta? In this also chromium having +3 charge. And +3, chromium having science teacher very cruel. 3d4, 3d3, right? 3d3. Now, out of these 4, if you know the electronic configuration, which will form inner orbital complex, right? You have to identify which will form inner orbital complex. So let's write the, if I'm talking about NiNH3 now, then having d orbital like this. They're having 1, 2, 3, 4, and 5. They're having 1 electron. This is 3d. This is 4s. This is 4p. And this is 4d. Right? So this is 3d, this is 4s, and this is 4p. Okay, and this is 4d, right? So how we'll write this, beta? We'll write as a 3d8 as a 1, 2, 3, 4, 5, 6, then 7, and then 8, right? Now in S they having how many electron, beta? For octahedral complexes, now here the ligand comes into the picture, whether the ligand is weak or strong. So in this there is a no unpaired orbital. Okay, there is no unpaired orbital present in the 3D series, right, in their ground state. So let's see. CONH33 is a diamagnetic and it is an inner orbital complex. CONH3. Because one important note here, beta, just not observe ligand only. If the ligand are same, na, because in the previous question, all having same ligand, that is ammonia. So we know that if the ligand is different, then we know the spectrochemical series, and we can easily calculate which will produce more splitting or which will produce less splitting. But in case of metal having higher oxidation state, because in this question now all ligand are same, ammonia, 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 and ammonia, but in cobalt there are +3 oxidation state. So as the charge on the central atom, or we say oxidation state on the central atom increases, okay, increases, they will form what? Inner orbital complex. But it means they having more splitting energy. Yani splitting energy doesn't depend only upon the number of ligand or the type of ligand. It also depends upon the central atom, whether the central atom having positive charge or a higher oxidation state or a zero oxidation state. So out of these 4, cobalt show +3 oxidation state. And due to this, they form inner orbital complex, or we say diamagnetic. Why diamagnetic, beta? Because in this there is no unpaired electron. There is no unpaired electron. And what is the configuration, beta? Configuration become, if I'm talking about CFT, then this is EG orbital and this is T2G orbital, right? So in T2G orbital, they having cobalt +3. That is cobalt +3. How much? Science teacher very cruel, mange fair copy. 3D7, it means 3D6. So how will write 3D6 beta? 1, 2, 3. Gap is very much. 4, 5, and 6. Okay. So the electronic configuration become 3, 2G6 and EG0. So this is how we can write the electronic configuration. Is it clear to you? Any doubt, beta? No? Is it clear? Okay. Now, the next question is what the question 39 asked now. FeCl3 plus potassium thiocyanate gives us the product, and the color of this product is whether its color is red, chocolate color, Prussian blue, or colorless. So you have to identify the color when the FeCl3 is treated with the potassium thiocyanate. Then what is the color of this product? First of all, let's see what happened when the FeCl3 is treated with potassium hydroxide. Which element is formed, which compound is formed, right? So whenever the FeCl3 is treated with the KCN, okay, KSCN, then the formation of FeSCl thrice plus KCl takes place. Now, is it clear to everyone? That is option number A. Okay, that is option number A. Whenever the FeCl is treated with the potassium thiocyanate, the product color of this product is red. Right? Okay. Now, the next question is which of the following can react with both HCl and NaOH? So we know that the type of compound, molecule or element which act as a both acid and base is known as what, beta? Is known as amphoteric, we can say, amphiprotic, we can say. So which of the following can react? So you have a option, right? Out of these, which two having same, which two having can react with both HCl and NaOH? Okay. So tell me the answer, beta. Yeah. ZnOH2, BeO, Al2O3, all of the above. Yes. Good. So the correct answer here is all of the above, because Al2,3, ZnOH, BeO, they all are the amphoteric oxide. And whenever they treated with the HCl and NaOH, so they will form all of this. Okay, depending upon the requirement. Now, when ferric chloride react with the potassium thiocyanate, we already discussed now. Yeah, we already discussed this, and this is the equation. You must remember, beta. Okay. Now, ZnOH to BuN2 are the amphoteric, so they cannot react with both HCl and NaOH. Next question, and this is one of the very important question. So what the question asks, beta? In this question, the backside attack on 2-bromobutane by methoxide give the product shown below. Which Fisher projection represent the 2-bromopropane? Okay, which Fisher projection represent the 2-bromopropane? Right. So you have to identify the correct one. Okay, so we know that for SN2 reaction, right? For which reaction, beta? For SN2 reaction. So in SN2 reaction, inversion takes place. So the configuration get reversed. ये याद रखना कि in SN2 reaction, what takes place, beta? Inversion takes place. And so the configuration of the gas is reverse. So the configuration of the gas is reverse, right? So which one is the correct out of A, B, C, D? Yes, tell me fast, beta. That is D, because this is SN2 reaction and their configuration is totally changed. Okay, good. Now, what is the IUPAC name of the following compound? You have to tell what is the IUPAC name of the following compound, beta. Yes. Tell me the IUPAC name of this following compound. What is the IUPAC name of this following compound? Okay. Let me, first discuss some basic things, because I know you just forget this thing, right? then only you are not able to do this question. Otherwise, this is a very simple question. So we know one basic rule that whenever count the number of carbon with the preference one. For example, if I'm talking about this is my carboxylic acid carbon, right? And one having double bond and one having ester group. So when the substitute double bond and functional group, both these three are present, then always prefer functional group. Always prefer what? Functional group, right? So numbering is a start according to the functional group. If the double bond, functional group and substitute are present. If no functional group are present and only double bond and substitutes are present, then always start numbering from the carbon where double bond approaches near, right? So according to this question, what is the IUPAC name? What is the IUPAC name, beta? What is the IUPAC name of the following? That is 4-ethoxycarbonyl pentene. Okay, let me first write the name. Okay, that is numbering 1, 2, 3, 4, 5. Okay, so this is the longest chain, I guess. Okay. So what is the name, beta? That is the 4-ethoxycarbonyl pentene. Okay, that is the 4 पे ethoxy lag gaya. Ethoxy means what, beta? Like this we can assume this na. ऐसे assume करो. CH3, Ca, C double bond CH, CH2, C double bond O and OH. Just assume like that. This one having two group, that is CO group, and ROR group, right? That is C2, C2. Yes, yes. Tell me fast. Yes, beta. That is ether group, right? So this is ROR. That's why their name become 4-ethoxycarbonyl pentane 3-ene oic acid, right? So the correct name for the 42 question is A. That is a 4-ethoxycarbonyl pentane 3 enoic acid. Okay. Now move to the next question. What the question asks, beta? The value of spin only magnetic moment for one of the following configuration is this. What is the correct one is? इसमें the correct one क्या है? तो भाई साहब magnetic moment how much it comes out to be? It comes out to be magnetic moment is equal to 2.84 Bohr magneton, right? So what is the value of magnetic moment is given? Magnetic moment is given is 2.84. Now, what is the correct option? So we know that now 284. 284 means how many unpaired electron, beta? Because we know the formula. N plus 1 or 2. Yes, that is N plus 2. Okay. Is this correct? Is this correct? N plus 1 or N plus 2? Yes, that is N plus 2. Now, if I'm talking about 2.83, 2.83 means almost 3. So in which case 3 comes? When the lone pair is, oh sorry, number of unpaired electron become how many? For example, let me give one example, then after you can solve, right? If I'm talking about Mn plus 2, right? So Mn plus 2 having electronic configuration 3d5. 3d5 means how we can write, beta? That is 1, 2, 3, 4 and 5. So they're having n is equal to 5, right? So what is the magnetic moment here? That is n plus what? 2. So what comes out to be? This n is 5, 5 plus 2, 7. 7 5 is the under root 35. 35 under root means 36 we know. So this is 5.85. Right? On the similar basis here also, if magnetic moment is already given, magnetic moment comes out to be 3. What does it mean? What does it mean, beta? Here n is, yes. Okay. Now the value of the spin only magnetic moment for one of the following configuration, that is 2.84. Now you have to identify whether it will a strong field ligand or a weak field ligand. Now here it's already given that D4 configuration is given. Okay. So if I'm talking about D4 configuration, so in CFT, two possibility are there. That is in case of octahedral, na, this will be called as T2G, this will be called as EG. If the energy gap is less, and when the energy gap is less, beta, when the ligand is weak, then how will you write D4? We can write D4 as 1, 2, 3, and 4. This is one criteria. Okay. So in this, they having a 4 unpaired electron. This is not possible. This is not good because we know Bohr magnetic comes out to be 2.84 only. So according to this is not the correct one. Now, what is the next option? That is in this, the energy gap is very, very. The energy gap is very, very big. Now, the first electron fills here, second electrons, and third electron, right? Okay. Now, if the energy between T2G and EG is very much, if the energy between T2G and EG is very, very much, then these electrons are repeated back here also, है ना? It means it will become, yeah, this one. So how many unpaired electrons are left? Only two. So N is equal to 2 only. And for corresponding to 2, we get the magnetic moment like 2 into 2 plus 2 under root 6. Okay, so this is under root 6 or under root 8? Under root 8, right? Because this is 2 plus 2, 4, 4 to the 8, under root 8. We know under root 9 is equal to 3, so this will become 2.84. So I guess this is the correct way. Okay, so whenever such kind of questions are coming now, just try to stick on your concept only. If you are good in your concept, if you know the spectrochemical series, know the ligand strength, know which ligand is weak, which ligand is strong, how to draw the CFT diagram, how to write magnetic moment and all, then for you this chapter become very easy, right? Okay. Now, next move to the next question, that is the function of sodium pump is biological process operating in each and every cell of all the animal. Which of the following biological importance ions is also a constituent of this process? Okay, so except this sodium, और बताना है आपको whether it is a calcium plus, double plus, K plus, Fe2 plus or Mg2 plus. So this belong to the first group, na? K plus, potassium. So I am having minimum ionization energy. So the function of sodium lamp is biological process operating each and every cell of this animal. Which of the following is a biological importance ion is also constituents of this pump is K plus. That is potassium. Right? Okay. Now, next move to the next question. That is question number 45. In this question, what they ask, beta? Lessingen test used in the qualitative analysis to detect what? So basically, Lessingen test is used for, we only know that it is used for the detection of nitrogen only. But this is not the truth, right? Nitrogen, sulfur, and chlorine. Okay, these all are obtained in a qualitative manner by using this test. Okay, so all of these are the correct option for this question, right? Next. Okay, in question number 46, this is very simple question, you know, the decreasing order of the second ionization enthalpy. This is the easy question, but this type of question must be handled, you know, in a very good way. Otherwise, if you do it in a hurry, then definitely it will become wrong. Okay, so for this question, please give sufficient time for such question. Then only you are able to you know, do a right answer for this right questions, right? So the decreasing order of the ionization energy of K, Ca, and Ba is, and this is called the second ionization enthalpy. We know that Ka belong to first group and Ca belong to second group, and Ba also belong to second group. Beta mange car scooter Bapraji, right? So if one electron is removed, it will become noble gas. Which one? That is group 1. So after the removal of one electron, they behave like a noble gases having fully filled electronic configuration. Similar, on the similar basis, okay, if I'm comparing calcium and Ba, okay? So calcium having electronic configuration 1s2. It means they are also very stable. Why they are stable, better? Because we know that half-filled and fully filled electronic configuration are much more stable. Okay, so this one is also important. But in this question, they are asking about the second ionization enthalpy, not the first one. If they are asking only the first ionization enthalpy of beryllium or magnesium, then it will be definitely very high. But if I'm talking about the second ionization enthalpy, so after removal of one electron, it will become 1s, or we say 1s1, right? So it will become 1s1, and from this electron is easily ejected, right? So what is the correct order? What is the decreasing order? So maximum number of second ionization enthalpy is shown by, okay, maximum second ionization enthalpy is shown by which pair, beta? Whether it is a calcium, potassium, or beryllium. So let me discuss this. That is the Ka having maximum. Why, beta? Because why K having maximum, beta? Because after removal of one electron, second electron have to be removed from the octet, and which is very difficult to do that. Okay, so the correct option for the 46 question is, that is D. Okay, it means K greater than, now K greater than, okay, so K greater than Ba greater than Ca. Is this correct? Is this correct? K is greater than Ba, accepted. But BA and CA both belong to the same group. Just remember this. Many of the students doing this mistakes very commonly. BA and CA both belong to the same group. Now, if I'm talking about the size, then calcium lie above, that is the beta, mange, car, scooter, baprachi. And BA are very large in size. So this factor also impart because they all having 1s2 electronic configuration fully filled. But BA is itself a large molecule as compared to Ca. So BA is supposed to be show minimum ionization enthalpy. So what is the correct order, beta? That is K, Ca and Ba. So this is the correct, not this one. Many of the students did this option correct. This is not the correct way, beta. You have to, understand the concept behind this. Then only you can able to choose the correct one. Now, which of the following pair form the same osazone? This question I already discussed when we are discussing the paper. Now, then this question we already discussed in our JEE first paper. That's with glucose and fructose form osazone. Okay, so which of the following pair form the same osazone? That is glucose and fructose. Okay, so this glucose and fructose form the same osazone. Now, next move to the question number 48, beta. That is a mixture of 2 mole of carbon monoxide and 1 mole of oxygen in a closed vessel is ignited to get carbon dioxide. Okay, now you have to identify that delta H is equal to delta E or greater than or less than, or none of the above. So first of all, let me write the equation for this question. What the question state now? A mixture of 2 mole of carbon monoxide and 1 mole of oxygen in a closed vessel is ignited to get carbon dioxide. So this is 2CO plus O2, and this will gives us 2CO2. Now these all are gases. So what is delta Ng, beta, here? Delta Ng comes out to be 2 minus 3. That is minus 1. Okay? So delta Hg comes out to be minus 1. Now we all know that one very important relation, that is delta H is equal to delta E plus delta Ng RT. Done. Delta H is equal to, this is the relationship between the enthalpy and the first law. That is delta H is equal to delta E plus delta Ng RT. Right? Here what the delta G is, beta? Delta G is minus 9. So we can write like this. Delta H is equal to delta E minus delta Ng RT. Done? Now we know that delta H plus Ng. Ng is what? Ng is Nj is -1 here, so equation become minus. So what is delta E comes out to be? Delta E comes out to be delta H plus delta Ng RT. So delta E is more than delta H. So which one is the correct option, beta? That is B. Okay? So in this question, which one is greater? Because as we see now, delta is sum of delta H plus some quantity, that is H. Okay? Right. Now, the halide which is inert to the water is out of this PCl5, SiCl4, BCl3. Which halide is inert to the water? So this is very famous question, and I hope everyone, you all read about this. That is SF6. Why? Because in SF6 now, just look at carefully. In HF6, there are 6 atoms of fluorine, and due to this high steric effect, okay, so due to presence of 6 fluorine atom and due to the repulsion takes place between these, their ionization enthalpy is what? Their, yes, okay, it means the halide which is inert to the water is SF6, right? Because they are having 6 atom of S in the small region, and due to this they are inert. Okay, so I hope this is clear to everyone. Okay, now next move to the question number 50. That is 1 mole of water is converted to vapor at its boiling point. Okay, so 1 mole of water is converted to vapor at its boiling point, which is 100 degrees Celsius and 1 atm. For this process, which of the following statement is correct? तो तुम्हें इस process के लिए बताना है कि for this process, which of the following statement is correct? Okay. So as we know now, beta, this is for boiling. So in boiling, phase transition takes place. That is from liquid to gases. Okay. So due to phase transformation of 1 atm liquefaction, free energy is always 0. Okay, so just remember this point. In case of phase transformation, free energy change is always 0. So delta G is always 0 in case of beta phase transformation, right? Okay. Now the oxidation number of phosphorus in ATP. So ATP contains phosphate ion, right? PO4 thrice negative. So how will you calculate, beta? How will you calculate this? Yes, because we know that PO4, we have to calculate the oxidation state of X. So X plus 4 into -2 is equal to -3. So we can say that X comes out to be +4. Okay? So ATP has a phosphatic group. So what the question asks in this? That is the oxidation number of phosphorus in ATP, that is adenosine triphosphate. It comes out to be, beta, how many? It comes out to be 5, right? Okay. Now let's move to the next question, and this question is basically numerical value type question. So the total number of stereomerism in an open chain aldohexose such as glucose is. So you have to identify the number of stereomerism in glucose, or we can say in the open chain aldohexose. Okay. So what is the total number of stereoisomer, beta, in open chain aldohexose? Okay. So just observe this carefully. In this given structure, this is the structure of glucose, beta. So the carbon having a star mark are yes, they are chiral carbon. Okay. So the number of chiral carbon in an open chain aldohexose such as glucose is 4. Therefore, the minimum number of stereomerism is equal to 2 की power n, so which is equal to 16. Okay, this is equal to 16. So this is the number of carbonyl in open chain aldohexose and such as glucose, and is 4. Therefore, the number of isomerism is 2 raised to the power 4, that is 16. Okay, now this question, that is question number 53. Here, the formation of enthalpy is given. Now you have to calculate the enthalpy for this reaction. Okay, and we have to calculate enthalpy for this reaction. That is NO2 3CO plus Na2. How will calculate, beta? Just look at here. We know that enthalpy of reaction is equal to enthalpy of product minus enthalpy of reaction, right? So this is the enthalpy of, this is the formula for finding the enthalpy. So this is enthalpy NT plus enthalpy of CO2. Now, as we saw ना, क्या देखा बेटा यहाँ पे एक चीज important, that is value for the each molecule is given, that is for CO, CO2, N2O, NO2, these all values are given, right? So how will you calculate beta? We know that N2O, how many HF, that is 81 plus 3 and minus 393, minus 2 into 34 minus 3 into 110. So these all are the value. This value is already provided to you. Okay, so on solving, what do we get beta? 836. And this minus indicate that, and this negative sign indicate that heat is released here, right? Heat is released here. Okay, so this is the required condition. Now, what the question 2054 demand? That is the maximum number of electron with N3 and L3. N3 and L3. We all know that N3. So maximum number of unpaired electron, that is 3 ka square, that is 9. Okay. So this is all about number of electron in, if someone say N is equal to 3. But in this question also L is given. So N is 3 and L is also 3. L is also 3. Okay. So as the 3s orbital does not exist. कभी होता है क्या 3d सुना होगा, 2p सुना होगा, 1s होगा, ना तो कभी 1d सुना है, ना कभी 1p सुना है. उसी तरीके से बेटा 3f is nothing. Okay. So as the 3f orbital does not exist at the value, cannot be liquefied, and hence no electron can be accommodated. Right. So no electron can be accommodated. Now next question is, a 500 gram toothpaste sample has a 0.2 gram of fluoride concentration, right? What is the concentration of fluoride in terms of ppm level? We all know what is ppm. That is parts per million. Okay, that is parts per million. So you have to identify the concentration in the terms of parts per million. So we know that as 500 gram of toothpaste has 0.2 gram of fluoride. Okay, so 1 gram having 0.2 upon 500 and 10 ki power 6 gram of toothpaste having this. So this comes out to be 400 gram of fluorine negative. Hence the concentration of in ppm is 400. If the question is not from ppm, then only for presentation, then we must use 100 instead of 10 ki power 6. Right? Okay. Next question, that is question number 56. Okay, so what the question 56 demand from us, beta? It will say two glass bulb A and B are connected by a heavy small tube having a cross sectional. Bulb A has a volume of 100 centimeter cube and contained the gas, while the bulb B was empty. On opening the stopcock, the pressure of fell down 40%. What is the volume in ml of the bulb? Yeah, this one is some interesting question, and some we can say a little bit hard as compared to the other questions, right? Okay. P is already given, that is P1 ATM. We can also calculate P2 like P1 into V1 V2 करके, ठीक है? So we get P2 as a 0.40. Now at a constant temperature, we know that from the Boyle's law, that is PV is equal to constant. It means what? It means that is P1 V1 is equal to P2 and V2, right? So this is P1 V1 is equal to P2 V2. From here only we can calculate this term V2. Okay, so by using this, we can calculate our value, that is V2. Values are given, just put the formula and you get them. Right? Okay. Now, next move to the question number 57. Right? So what does the question 57 suggest, beta? That is the equilibrium constant Kp for the homogeneous reaction is 10 raised to the power minus 3. And the standard Gibbs free energy is in kilocalorie mole for the reaction at 27 degrees Celsius is this. Write your answer after the rounding off to the nearest integer. So we know that what is the relationship between beta delta G and log P? Yes, this one. That is delta G is equal to minus 2.303 RT log P. Okay. And we know that that is 2.303 remains same. R here 2, T temperature and Kp become minus. Okay. So what is the Kp here beta? Kp become minus 3. Okay. Yeah. So this will become this much of amount, that is 4145.4 calorie per mole. So this is the amount of energy released. Okay, gives free energy, or we say free energy. Now, similar basis, time required for complete decomposition of 4 mole of water using a current of 4 ampere. So here mole is given, that is 4 mole. Current is also given, that is 4 ampere. 4 ampere, any water using a current of 4 ampere. And the time required. So this is the time required is given. That is y into 10 ki power 3. Just you have to identify the y. Okay. So what is y here, beta? Just observe carefully. To decompose 1 mole of H2O, we need 2 moles of electron. Obvious, because it is a 2 farad. To decompose 4 moles of H2O, we need a what we need a 8 Faraday. Okay, तो अगर 1 मोल के लिए 2 Faraday चाहिए तो definitely to decompose a 4 mole we need 8 Faraday. Now Q is equal to IT. So just put the formula and then you can calculate your time. Your time comes out to be 1.93 into 10 to the power 5 second. So this is how you can calculate, right? Now next, move to the next question, that is 59, 60. These two are the last question. Basically, what the 59 question state now, the photochemical reaction A to B is given 1 into 10 to the power 5. Mole of B were formed to be this, and quantum efficiency is pi by 2, where X is. What is the value of X here? Now, number of mole of A reacted is equal to 1 into 10 to the power 5, or we say 10 to the power 15. Number of molecule A is equal to this. So quantum efficiency means what? That is number of, that is number of molecules. Okay. So quantum efficiency. So we can calculate this by using quantum efficiency. That is comes out to be 0.50, or we say 50%. Right? Okay. Now, last question, that is the temperature coefficient of the reaction is 2. Here the temperature coefficient is what? At the average rise, 10 degree rise in the temperature, the equilibrium constant become twice. Okay, so the temperature coefficient of the reaction is 2 when the temperature increases from 30 to 90. Then the rate of reaction is inversely by x. What is the value of x here? So this become 2 raised to the power 6. Temperature coefficient is twice. That means the rate of reaction double at every 10 degree rise in temperature. So from there, that is 30 to 90, this value comes out to be 64. Right? So we discuss almost all questions that were coming in your today examination, that is out of 30 we are discussed, and try to learn new questions as well from the PYQ revision. The main purpose here to teach you after the class now, to understand what type of questions they were going to ask in your coming examination as well. Right. So by doing question, just remember that how many types of कितने कितने अलग अलग तरीके बन सकते हैं क्वेश्चन को करने के. Just try to understanding things. Once you start understanding things now, try to making how different types of questions, that yes, from this time this type of questions are coming from this chapter. Now what next step is, what next step should be from the coming examination, what kind of question basically they were going to ask, so you get the idea that how the questions are coming in the examination. So just do it, practice as much as you can, and we'll meet you in the next class with a new chapter, that is aldehyde and ketone. This chapter is also very going to be very much more interesting. So let's end this session with this question only, right? And let's meet in the next class. So take care and just study with the cool mind.